2 on page 118.
On page 120, did you have a preference for number 1 or number 2?
Anyone.
Anyone? Okay. We have no time. They're only like 5 pages. 1, 2, 3, 4, 5. We probably better get through all of them today. Okay, let me just do like 3 on page 117 just to give a basic background. You're going to be looking at concepts of molarity, molality, mole fraction to kind of figure out colloidal properties. And so page 117 is very straightforward. You have percent by mass, right? For page 1A. You have percent by mass, you have 1.457 molar solution of maltose. So it's a sugar. Therefore, if you put sugar in water, it's not like salt where it dissociates to ions. Basically stays together. It has a density of 1.188 grams per milliliters for the solution. Calculates volume. Okay. So for part A, we're looking at the percent by mass of maltose, right? So how do we calculate this? We find the mass of maltose. So our solute over our total mass. And we find the percentage, right? Okay. So how do we find the mass of the maltose? Feedback.
The molar mass of carbon, hydrogen.
Oh, well, we have also, yes, that's true. We find the molar mass of maltose, right? And we know that in a 1.457 molar solution, it's moles per liter, and if we're assuming this, then we can just do simple stoichiometry, right? So, for the mass of maltose, so we're on page 117. So we have 1.457 moles times the molar mass to be 42.296 grams per mole. And this will give us 498.72 grams. Right? So now we know our numerator. For our denominator, we're going to use our density. So it has a density of 1.188 grams per milliliter. 1 liter is 1,000 milliliters, right? So using that property, I convert liter to milliliters times the density, and density is 1.188 grams per milliliter. And this will give me grams. So 1,188 grams of solution total. And now we have our denominator. So we just plug this into this formula, and we're going to get 41.9%. Right, very straightforward. It's very simple. Okay. So molality is actually a little different than molarity, what you guys have normally been working with. So I'm going to use like a lowercase m to denote molality. Molarity, I'm going to use an uppercase m, right? So this is going to be equal to moles of solute over kilograms of solvent. Well, we already know the numerator because we found that up here. And also they tell us it's 1.457 molarity, right? Moles per liter. So we know that this is 1.457. That's straightforward, no calculation necessary. The bottom, we know our mass of our solution, right? And we can also find our mass of our solute. So if we subtract the two, we're going to get the mass of our solvent, correct? And we get that in grams, we convert it to kilograms. Okay. So here on the bottom, we have 1188 grams of our solution minus 498.72 grams of our maltose. And that's going to give us 689.27 grams of our H2O solvent. Convert this to kilograms and we get 0.689 kilograms. numerator, and we can solve for molality from there. So it's 2.1. Okay. So one more. We're going to look at the mole fraction. If we look at the mole fraction denoted by X is going to be equal to moles of solute, because here, for C, we're looking for the mole fraction of maltose, right? If we're looking for the mole fraction of, say, water, then in our numerator, it'll be moles of water. But here, we're just looking for maltose. Okay. So moles of solute maltose over total moles, right? So moles of solute, we already know from up here that it is 1.457, right? So that's simple. Our total moles, how do we find that? Well, we have our moles of maltose plus our moles of solvent, total moles. So total moles of solution. So here it's just 1.457 maltose, moles of maltose, plus we have we know how many grams of water we have here, 689 grams of water. We can just convert that to moles of water, and that'll be our moles of solvent. So we actually get 38.29 moles of H2O, and that's going to be 39.77 total moles. And that's just in our denominator. Plug this into our calculator, and we're going to get 0.037. Okay, so this is just basic background math that we're going to need to use for our colligative properties, right? You guys are completely familiar with this. Questions on this? No? Okay. So let's look at colligative properties 1. We're looking at page 118. Let's do, so we want to do number 2, right? Are there any other ones here that we want to do? No? Okay, let's just do number 2. So when I look at a problem like this, I have sucrose, right? I have 1.06 molar solution of sucrose has a density. So when they give me density, I know that I can find the grams of the solution, right? And if they give me the molarity of solute, then I can find grams of solute.
Number 2 or 1B?
I'm doing number 2. I'm doing number 2. Sorry, I'm doing number 2. Okay, do you guys want to see number 1? Or do you only want to see number 2? Number 2? Okay, let's do number 2. A solution containing 0.674 grams of one type of interferon in 157 milliliters of aqueous solution has an osmotic pressure of 4.15 torrs at 25 degrees Celsius. Okay, so the formula for osmotic pressure is I is equal to mRT. This should look vaguely familiar to you guys. Does this look familiar? Does this also look like PV is equal to nRT? Does it? So if I move the V over and over volume, this is molarity, right? Times RT. So it's essentially what you guys have been working with this whole time. Here I am denoting pi as the osmotic pressure, and M is of course molarity, R is your constant, and then T is going to be in Kelvin. Okay? So, looking at this, I know my R is going to be 0.0821 liter times atmosphere over mole times charge. Okay? And then my T, it tells us at 25 degrees Celsius, remember to convert to Kelvin. So 298 Kelvin. Pressure is going to be, so they give us 4.15 torr. I just want to convert to ATM. So 4.15. If I have torr convert to ATM divided by 760, right? So 4.15 over 760. Because over here I have ATM and I want to keep everything constant, right? So Kelvin, atmosphere, I want to keep everything constant. Okay. And then it's for the liters of solution, we have M, which is actually moles over the liters. So we have 0.157 liters, right? 157 milliliters. And all we do now is just solve for this N.